Thank you very much for the presentation. First of all, I would like to give many thanks, especially many thanks to Daniel, to Jesus Anserna, Jose Antonio for inviting me to take part in this very impressionant event. Really, it's a pleasure to me be with this very big collection of super class speakers in different worlds related with the big data. The title of the talk is Using Big Data to Fight Against Wildfire, but really maybe more clear could be using the information of big data to fight against wildfire. Because really we are creating in the last year some new methodologies, and we are illustrating these new methodologies with a big collection, unfortunately, big collection of data that we can have related with the wildfires. Okay. Well, I also have to give the thanks for helping in the organization of this presentation with these two students, María Isabel Borrajo and Isabel Fuentes, older students of my university, and also María José Ginzo Villamayor, who is the coordinator of our research group. Well, I am the leader of the research group in statistics in the now known Department of Statistics, Mathematical Analysis and Optimization in the University of Santiago de Compostela. Well, here is these people, and also I have to give many thanks to Manuel Marey. He's this person related with the forest engineering, and he was the clear contact to take all this collection of data corresponding to the wildfires. This is the outline. I can understand that we are very tired after the long journey, but I will try to be maybe more short in my presentation and avoiding many technical aspects related with the different parts of the talk. Well, the outline is one introduction and motivation of the problem of the wildfires, and then I will present three new approximations that we could got in methodology related with the spatial point process, the comparison of point process, and the testing of the spatiotemporal supposition in the point process. Finally, I will give some talk about related with the future research. Well, with respect to introduction, wildfire, of course, my motivation is in Galicia, where I am now living, but wildfire is a global problem. Okay, so this is a global environmental threat, and here is one sample of 2013 showing the different wildfires that you can see along of the wall. There are different reasons of the wildfire. Sometimes are religious, other times are in the case of our community, I think, social factor influence in the reason of the wildfires. So really the phenomenon of forest fires then is a big ecological problem. And now in the last year with increasing in the intensity, of course as a very serious economic consequence, not only from the environmental viewpoint, but also from the economical viewpoint. There are several thousands of fires in the southern Europe, and a big proportion of burning area of forest every year in this part of Europe. In particular, in Galicia, the number of fires, for example, between 2000 and 2006 was more than 7,000 each year, with almost 100,000 hectares being burned only in 2006. Well, that means that we are in the newspapers, not only to the regional level, in the national level, and also in the international level. For example, this is a collection of news in 2017, where we had a very atypical year, corresponding, for example, to the October month, where almost we had the fire inside of Vigo. I think there is some people of Vigo here and can say directly to you that this is clearly true. The fire was really in the town, almost. Okay, so this is really a very, very dangerous situation. Well, about Galicia, we are exactly in this corner of Spain, the northwest of Spain, and there is a high wildfire incidence. Of course, the climate conditions are necessary, but are not sufficient. Okay? So then, of course, if we have a dry period, we have higher probability of wildfires. But not always is explained directly as a consequence of the climate reasons. And also, with respect to Galicia, we have a big proportion of wildfires arson. Okay? Of course, we are using the codification that the autonomous government gave us of every wildfire. Okay? And many of the wildfires are very small. Okay? So, of course, it's very important to understand the behavior of the wildfires and to be useful for the fire prevention and the fighting plans that can be designed for the fighting with wildfires. Well, really, I am the dean and I am the leader of the research group. My talk is biased to my interest, statistical interest, but really this is part of a very big project, Enjambring Spanish firm, that started 3 years ago, where in connection in the university and the Babcock International Aeronautical Company was designed under the plan of research in Spain, nominated 100. Okay, so using this plan, we could apply and get funds for different problems related with the fighting with wildfire. So here is more or less some information about the project and about the people who were working in the project. Not only people, but also people of our master, young people are helping in many practice with the data that we have related with this problem, okay? So there are many different problems related with the fighting with the wildfires. Many of them are from the operation research world, for example, the research management. There are also geometrical problems, as for example, the algorithms designed for the anti-collision, problems related with the forest inventory, and also problems that try to explain from a physical viewpoint the effect of the temperature in the decreasing of the size of the wildfires. Well, as I told you, I will be devote my talk from the statistical viewpoint, and I will try to illustrate some methodology that we could obtain in the last 3 years in the context of the wildfire data set. So, really we have a very big collection of data. I only illustrate in my exposition the methodology related with the geostatistical coordinates, but every wildfire have a lot of information associated. So we have really a clearly big data problem, okay? So this is more or less the number of wildfires for a period of 16 years. And these wildfires are classified in function of different factors. For example, with respect to the burning area or for respect with the cause of ignition. And here is a evolution along of the years with respect to these different factors of classification. For example, it's very, very impressive to see this year, 2006. I will illustrate sometimes with all collection and sometimes only with 2006, because 2006 was really a exceptional year where all Galicia was completely full of wildfires, and the size of the burned area was really very big. Here you can see a photo, a Meteosat photo corresponding to one day in August. I can tell you, in one of the days of August, I stay completely blocked, trying to go to one airport and fire around of me in the different directions in the highway. So it was really an impressive year. Well, there are many questions that we can have related with wildfire. For example, which is the spatial distribution of wildfires? What about the interaction in the events? Which factors can explain the occurrence of wildfires? Have the same distribution, spatial distribution, the wildfires are somewhat natural. Can observe a change along of the time of the spatial distribution? So there are many, many different questions that we give some answers, creating methodology for the question. Well, again, I am speaking from the statistical viewpoint. In this talk, of course, for obvious reasons of the time, I will be concentrating in some kind of methodology that we use related with point process. But also, we work with other different models, models with random effect, semi-parametric prediction models, and many other different we're working in the group. I will illustrate in this talk only with point processes, okay? Well, which is a point process? So a point process is a stochastic process, governing the location of a finite number of events in a relative space. In our case, the illustration, of course, will be the map of Galicia. So both the number and the coordinates are random. And a point pattern is a realization of a point process in the corresponding bounded domain. Well, additional to the information of the geostatistical coordinates, we can have a marked point process if we have marks associated to the geostatistical coordinates, or we can have covariates. And in summary, the number of events and sample size is random. Events may not be independent, and we have a problem of boundary support. That, of course, has a consequence of the boundary effect problem. Well, here is illustration of the pictures in the context of point process. For example, in 2006, here is the spatial vision. I only observing the spatial coordinates of the wildfires in 2006. And here is the evolution in the time of the events along of the year of 2006. You can see clearly, more or less, the situation that we found in the photo previously. Here is the August month with an explosive quantity of wildfires. Of course, in one aspect, we have the spatial point process. In the other photo, you have the temporal point process, and you can design the combination of both and use the spatio-temporal point process. Well, people in statistics related with these models work many times with the supposition of stationarity, isotropy, and for example, the complete spatial randomness. That means that the events are independent. The number of events is a Poisson and is uniform distributed in the region. Okay, and for example, working with the supposition of Poisson is very important, the first order intensity. Here is the function where I will be concentrate. Okay. Second order properties are also of interest and related with the interaction between the events. So more or less, I will be concentrate along of the talk in the explanation of the first order intensity of my wildfire data. So then, coming back to the questions of before, which is the spatial distribution of wildfires. So I will illustrate this answer, estimating the first order intensity. Okay? I will not be concentrating this talk in the second order analysis about which factors explain the wildfires. So I will try to create a new estimator based on covariates. About the question related of the comparison of the spatial distributions, we also show new methods for non-parametric comparison of intensity functions. And finally, I will show you a recent non-parametric separability test that we obtained to try to analyze the possible dependence between the space and the time. Well, about the first order intensity function, here is the mathematical definition. This is essentially the expectation of the number of events per area, per volume, okay? And is quite related with the density, because the density is the frequency of events, okay? So the difference really is only if we are counting or you are using the frequency, relative frequency of the data. So if this function is constant, we have the point process is homogeneous, and in other case, the point processes are inhomogeneous, and we are in the world of curves, and of course, we are in the world where we are experts along of the years, giving material, statistical material to estimate the curves. Okay. About the kernel intensity estimation, well, there are many ways, of course, to give a non-parametric estimation of the intensity function. Here is one of the first introduced by Deagle in the 80s. And the formula is, this is, of course, adapted to the map, because I will show the intensity in maps, okay? It's the formula for people who is in connection with density estimation is exactly the formula of density estimation, except that we are not divided by n, because n, in this case, is the number of data, and in the density is the relative frequency. Here is the absolute frequency. Okay? So this is the classical formula for kernel intensity estimation, where we have a bandwidth and a kernel function. And there are many ways to extend this intensity estimation function, going to more than one dimension. In fact, the paper of Deagle was devoted to dimension 1. And there are, if I am not wrong, I think Steve is here, he has a nice paper with Peter Deagle in JASA also in 1988, making relations already in that moment between the intensity estimation and density estimation. Well, we extend this estimator for a general situation in a map, and using a general bandwidth matrix for the smoothing. Okay? One of the problems that we have here in this context is the kernel intensity estimator is inconsistent. He's very useful and is very popular. There's a lot of use in the epidemiological context, is in the package, but from the mathematical viewpoint, it's not consistent because with respect to the density is not divided by n, so the estimation, the variance is not going to 0. So then it's good for exploratory data analysis because you can make comparison of the maps, but it's not consistent as estimator in the concepts of statistical viewpoint. Okay? So it's for that reason, about 10 years ago, a French school tried to introduce a function that can be also useful for exploratory data analysis, but that you can estimate in a consistent way. He's denominated the relative density. Essentially, it's the division of the density over the integration of the intensity along of the area. Well, we extend this estimation for a situation in a map. Here is our estimator. Of course, I will not give mathematical details. You can find in our paper in the Scandinavian Journal of Statistics 2 years ago, where we obtain a bandwidth and we define different algorithms, and also we define different resampling techniques to make inference along of the objective of the estimation of the intensity function. Well, illustration, for example, here we have data corresponding to, this is 1 year of provocate fires, and this is 1 year of natural fire. Normally, you will see many fires going to the south and going to the coast. A very important aspect. Unfortunately, I cannot give an answer today because we have the engineering people working in the distance of the geostatistical reference with respect to the high weight connections. I think will be a very important factor to explain the fires. But here, along of this red part, there are very important high weight connections to the north, to the south, and of course this is a social component, and it's a good way of movement of the people to try to get the fires. Okay. Here is the estimation of all these big data along of the years. Here is a special year, 2006. Okay, remember? I think the estimation is very useful from the exploratory viewpoint because you can see clear almost the high weight in the north to the south. Okay. Here is the intensity in natural fires, completely different picture, because in this case the high intensity is normally in the border between Galicia, the inside of Spain, and of course in this case there are a green part of Galicia, and many of these wildfires are clear of natural reason. Okay. Well, as I told you before, one important thing is try to create kernel intensity estimations that use the information of covariates. Well, this is a new thing in this field. Now, mathematically, the situation is this. I have the point process. I have one transformation of this point process. For example, the transformation could be the distance of the geostatistical reference to the more close high weight. Okay? Speaking with the people of the forest science, they say that could be also very important, the distance to a center of related with the problems of owners. Then there are discussions, the owners maybe could be other reason related with explanation of. So mathematically, that means that the intensity function can be explained in function of this covariate. Covariate in this case means that I can observe this variable in every point of the map. Okay? Well, if we are in this situation mathematically using the spatial cumulative distribution function of this covariate, I have very important, from the mathematical viewpoint, things that, for example, if I have a Poisson point process originally, the transform process is also Poisson,
and with the corresponding coordinates in the transform space. Okay. Well, a very important thing here is thinking in the language of relative density. The density of the transform process can be written in this way. This is a known function, and here is the function that I try to estimate. So it's very nice to see that this problem is clearly transformed in the problem we call a bias density estimation. So that means we have to use tools. For example, we got in a recent paper in non-parametric statistics for bias density estimation and create a new estimator for the intensity function. Okay? Well, this is the intensity estimation function that we think to use in the future related with the covariates in the Galicia map. Well, in the moment I have one estimation with and without covariates, I can use also this statistical tool to try really the testing of the covariate effect. Okay? So that means I can test the null hypothesis if my relative density or intensity function can be explained in function of this covariate. Well, that means that we are going to the possibility to apply our experience in goodness of fit and comparison of density and distributions in the past, in this case, to the context of relative densities. For example, we can use one L2 distance between these two estimators. Okay? This would be the estimator without the information with covariate and the information with covariates. Again, I am avoiding all technical aspects. We obtain the limit distribution of the statistics. We obtain the corresponding bandwidths for making this testing. We obtain some kind of resampling techniques for calibration of the distribution, in the way that we can give automatically maps of p-values about the testing of this supposition. Well, here is one illustration, not with the Galician data, about the Canadian wildfire data in 2015, I think so. Here we have the data corresponding to the wildfire. There are people of Canada. And here is the covariate corresponding to the temperature. And the temperature does not explain the intensity in Canada also. There are clearly more factors. In fact, the p-value of the test is 0. Okay. Well, about the non-parametric comparison of intensity functions. This is a very interesting topic, and we can think, well, for example, if we are changing the Earth zone and natural fires along of the different years, we can say, well, we have the same structure in the spatial distribution or are changing along of the time. Well, that means that we have, in this case, 2 point processes corresponding to one type and other type, and we can test, for example, the null hypothesis about if these 2 intensity functions are the same. Okay? So again, we can create one characteristic to be estimated coming of the density estimation world. There is a very interesting paper of Duong et al. In the context of density estimation. In this case, we are using the L2 distance between the 2 relative densities corresponding to the 2 processes, and of course, making the estimation of these 2 intensity functions, we can create one test that is possible to make calibration about the supposition of this null hypothesis. There are a lot of work about these statistics. Of course, there are many statistical mathematical aspects. We have a U statistic based in a point process, blah, blah, blah. We obtain the limit distribution. And an interesting thing here, many people use for the decisions the calibration with the asymptotic normality. The asymptotic normality that we have in the context of density estimation, but also in the context of point process, is not useful in practice because the convergence is very slow and there are a big distance between the through distribution of the statistics and the corresponding normal approximation. Here, one example you can see in some simulations. Here you have the asymptotic distribution for these sample sizes, and here is the through distribution approximated by Monte Carlo. Clearly, we need create resampling techniques for this approximation. I don't know if Eduardo is here. In other contexts, I remember that Eduardo was making some testing about the different sample size, maybe close to 1 million of data, the approximation start to be good. So, well, maybe with big data it's possible. Well, here is the illustration of the comparison of wildfires. Again, all the collection of data. Here is the collection of data corresponding to the 2006. Here, there are many suppositions that we can test. For example, if the spatial distribution change or not in function of the characteristic of the wildfire, of change with respect of the time. Well, here is, for example, the different estimations of the wildfires, arson wildfires. We made the comparison between every pair of situation, and clear we have very small p-values. So this is a problem for people organizing the fight, and because apparently every year is different, not exactly. So then it is necessary to work in a special plan every year. No, I cannot use, well, I have a plan to fighting with the wildfires and use this plan, the same plan of the years. It's not working. Also, with respect to the cows, also there are clearly difference of the wildfires. Well, in the last part of the presentation, I would like to speak about the methodology that we were developing in the spatio-temporal point process. So, one very important aspect is the testing of non-parametric separability. In this presentation, I only was working in exploratory vision of the data, of course. But if we want to design prediction models, based on not viewpoint, many people use suppositions, for example, of separability. So then I can many times use suppositions in my structure or model for prediction that can be not true. So I think it's very important to design checking tools of the suppositions. Okay? Well, thinking in the spatio-temporal context, the definition is the same, but now the coordinates are spatial and temporal. Okay? So here is the intensity for the spatio-temporal context. Okay? And we can try to design some tests about the separability. Well, thinking in the separability with the language of the intensity function means that the global intensity function can be written as the product of the marginal intensity functions. So this is very useful because we can work using all ideas of the epidemiological wall of compare the intensity functions, creating the ratio between the intensity function defined using the two arguments with respect to the intensity function only for the spatial context. So under separability, this ratio is constant. Okay? So this is important because I can try then to estimate the quotient of the intensity using two arguments or only the spatial arguments that are exactly the quotient of the relative densities using the temporal component or not. Remember that we create estimators for the relative density, so I can estimate the quotient, estimated the densities of the numerator and the denominator, and maybe it's useful work with some kind of transformation because, of course, density can be very close to 0, and also the log transformation is very useful. So, in summary, we can work with this estimation as answer of a regression model where we can test separability. So then, with this estimation, make it the estimation of the boundaries, for example, with least square cross-validation or other weight, we can go to the wall of the goodness of fit for regression models. So in that case, the answer is the estimation of the transformation of the ratio, and the covariate is the explanatory variable, in this case, the spatial coordinate. So we have two data, y and xi. The null hypothesis is that the regression have a constant mean. In the alternative, I can make estimation of the regression function, and then I can use one of the many different procedures in the literature for the testing. For example, the generalization of F-test of Bowman and Azzalini. So here is the F-test. So I have now the statistic, the estimation of the bandwidth corresponding to the alternative, and the estimation corresponding to the ratio. So this is again with different components, and also other very important component is the chi-square approximation in the calibration, as for example was used in the book of Bowman, or maybe more useful in this context, the permutation test, where we have constant regression, we only make a permutation of the covariates and the answers, and create a lot of possibilities of artificial samples and a lot of possibility of artificial values of the statistical test to approximate the critical value. We have many, many illustrations, but I would like to show only this example because I don't know if it is a big data example, but it was a big time of computation because I think we're making computation a lot of time because we simulate Galicia. Okay, we simulate Galicia under separability condition. So we make the estimation for this kind of files, of this size. We made the estimation of the spatial map, and here we have the estimation of the process with the temporal coordinate. And here is the map where you can see the very good calibration we have, for example, with permutation tests for example, 2 levels. Here is in green means that these values are in the corresponding empirical confidence interval. So this means the test is calibrated. I am telling you because many times, me for example as referee, on many papers people say I have a very powerful test. And then you see the level is not calibrated. So then what means powerful? No? So then here is the numbers corresponding to this example. And this was a very long time because of course we have made the program to simulate all the boundary effects corresponding to Galicia. Okay. Well, about future research, well, in summary, we have a lot of data. I am only using the geostatistical coordinate of every of these data, 100,000, but there are many, many other covariates, so we are in a really big data situation. And there are many, many possibilities. For example, try now, what about we have not separable situation for the prediction, test the possibility to increase the number of covariates in the explanation of the intensity function, and going, of course, to more high-dimensional separability problems. Also, with respect to the computational aspect, there are a lot of work, try to optimize the algorithms with parallelization. we are using many times our supercomputer Finisterrae 2 in Galicia, and of course including many of this software in the software air or many other relates. Okay, I don't know. Yes, I have maybe in the questions if you want. I have one movie with the example of one fire. So then I think it's very interesting because Paco gave us this movie corresponding to the fire of 2017. It's very interesting because along with the movie you can see that the many different information they have associated only with one wildfire. Because there, of course, you have the burn area. Of course, a very important thing is the estimation of the burn area, because this quite relates to the actuarial costs. Okay? And also, along of the control, they have the temperatures, they have a continuous control about the decisions where they have to go to find more. Okay? So there are many, many interesting aspects where I think the methodology of, as I told you, of this super class of speakers offered today, I think is a good field where we can apply methodology related with the modern big data. Okay. Well, I think I will stop here. Thank you.